Welcome everyone. This is Anish. The stimulant for today is a wonderfully fragrant Earl Grey by Vitards of London. I don't know if I'm pronouncing that right. And let's begin. Also, let me check. Yep. Let's see. Wait, what? How many integers can form an arithmetic sequence? Hmm. So one is if the midpoint is an integer. I see. So if the difference is, oh, okay, if they are the same, yeah, okay, all right. Let's say A and B get many numbers on lines. Mm-hmm. New line. Mm-hmm. Okay, what? That's much better. Now, okay, so I'll also try to explain my problem solving or the approach that I'm taking. Okay, right, yeah. First, this. Hmm. Equal is just one, right? Makes it like this. Man, yeah. Mm-hmm. So if it's even, then it's 3, else it's just 2. And 3. Okay, sure. 5 and 7. And that's 3, right? And choose again. 6 and 1. It's fine. Okay. Should work. Let's paste this here. 100 keys arranged in a row. Ninth key from the left is called key I. This is nice. N keys one by one. The I press key A I. What? Okay. Is this just a pure calculation? This looks like a pure calculation. Well, hmm. Clojure group by, I think. So, hmm. Let's create vector of maps. Mhm. And also have to define a custom leader for this. Fine, fine. Mhm. Lead, read line, then split on um, split line this regex. That should be yep. And then you just return is it yes. Sure. It's long str minus okay. I have a bunch of these. So mhm. Ah, let n be a number on a line, and then um, the other one, the next input should be a yep vector that is the result repeatedly for n times following. Yeah, yes, right. Yeah, cool. Let's just nice. Good. Let's say yeah, this thing. Mm-hmm. 3 and 6 up. Okay. Now by the second result of this thing. Oops. Cool. Mm-hmm. I want just those. Then transform the keys. A second, and then map B X there, and then returns. Yeah. Then what? Left or right. And way. And then transforms the way returns. And then map way first. Wait. Yep. Over the something. Um, how do I convert this into a map? Yeah, I'm just gonna do it. Yeah. Okay, this does that. Now, I just want to know fatigue. Some given vector of band positions, right? Yeah. Then it'll be let f what's happening. Hmm. First element, and now A. Yeah, I need to get the first and rest so that then I can run a reduce over the thing. So the reducer will have to know the accumulated fatigue and the current position. Right, right. Yeah, this shouldn't be hard. Reduce. If the initial value is cumulative 0 and initial value here. Wait, what? Oh yeah, okay, I'm function. Mm, that takes two arguments, ACC and current. Yeah, this should actually work. And then next, oh, yeah, fine. Right. Mm, sticking with that for now. And then returns just um, absolutely okay, fine, cool. CCC absolute value of hmm, okay over this and the rest of the vector. Ooh. Mhm. Mhm. Yeah. Yeah. What? This is the P2 input as it was given to us. Mm. Fair. Get this, then 6. Okay, compile this here. Okay. Yep. This is correctly parsed. 3 and blah blah blah. Okay. Mhm. Now, what from get in this thing the value of, let's say, L. Let what? Oops. How the hell is okay? Yep. Yes, yes. fatigue is 6, and then if I get the fatigue for the right, it's 5. So I said, okay, fine. Now, red line plus a plus the values of the input okay, yep, that is correct. Just go over the whole thing. Then we paste this. And there's no weird stuff here, I know. Nope, nope. Arithmetic subarrays. Hmm. Okay. This is 100, so they should always work within the time limit. Yep. Okay, this is clearly dynamic, I think. No, is it? Yep. Mm-hmm. Okay. This off. Distance. Give me a moment, guys. Something I want to check. Yep. This works. Okay. Let's say this is going to be a square matrix. From left. So we only have to bother with a certain part of said matrix, which is, let's just label them 1, 3, 3. From 1 to 1 is always is is always like a 1, of course. So the diagonals are always going to be a 1. That's a given, right? This is nonsensical. It means nothing. Forget it. 1 to 2 is also always going to be a 1, interestingly enough. Just one moment, please. Sorry about that, just a bit of logistical stuff. Now, thing is, we need to associate with it a difference. So the difference here is going to be a 0. So it doesn't matter, it doesn't do anything. The difference here is going to be the difference between these two. Okay. Okay, so let's take a, I don't know, sample array. Where is the thing? 3693. Yeah. Mm-hmm. Mm-hmm. 3, 6, 9, and 3. The difference between these two, yes, we can just ignore that. So you have to start with these one pairs basically. No, just the one pairs. Right. And every iteration will go down by 1 actually. Yes. Okay. So the difference here is going to be 1 to 2, 3, 2 to 3, also 3, and here -6. So, yep. Now this difference is the same, so this is going to be a 1 with the difference being 3. Once it's, this is actually a 2. Let's just draw division here. It's not 10 or something. You get the idea. Okay, cool. This is not going to be that because 3 is not equal to -6. So which is going to be a 0, and the difference is, I don't know, nil. No, nil. It doesn't matter. So yeah, so if it's if both of these are okay, fine. Both of these are sequences, which is the 1, and the difference is the same, then we can propagate that to the next. Otherwise, nope. Okay. Let's look at the input. So we need to check right. So we first need to construct this thing, and then go, yeah. What just happened? 3. So it's going to be a set of 2 pairs actually, and we could use 1 and 0, or we could use true and false, doesn't matter, but it's fundamentally going to be linear, so I don't have to worry so much about perf at the moment. Yes. How big is it? 10 to the 5. Let's see if it works, it works. If it doesn't, yeah. Okay, so let n be fine, yeah, fine. No, I don't think anybody cares, but you know, the AISD, get very number one, right? Cool. Okay, now I need to construct this vector, which is going to be a vector of these, these thingies. Yep. So I want map vector AIS. Um, what? Oh, sorry. To arguments, so it'll give me a set of two pairs. But I don't want a set of two pairs. I want a set of differences. So I'll just have to give it a function that takes in B and then, gives me back a vector consisting of true actually, and the difference of direction doesn't matter, but it's going to be consistent. So let's just do, what direction do they give? X. Okay, so the later plus. Okay, fine. Yeah. Cool. Let's give it the input and see what it spits out. Yeah, 2, 3, 2, 3. Okay, fair enough. Works. Now we need to reduce so this is basically a while loop. Mm, Okay. Get the problem 3 input. This is just this thing, except what? Oh. In root form. Okay. Now let is the key. This is a true loop. The initial row be of these things, right? Get problem 3 input, and then a loop with current row being bound to accumulator being bound to 0, current row being bound to initial row. Okay. Now recur actually can this be yeah, should be an eager map yeah. Found current row, right? Because no, wait, nope, 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 nope. Yes, accumulator filter, yeah. What's the predicate? Uh, Red item returns. Okay, fine. Build up first. If the first is true, let's just try this. Let's say, yep. Hmm. That's it for the accumulator. The next row is going to be formed by the process I pointed out before, which is I'm not considering the base case for now, just yeah, just this thing. So how do I process the current row? I go through the current row and the hmm, hmm. It's a map over a two. It's a map over a two of these arguments, right? Map P is it doesn't matter, but why not? Hmm. Eager evaluation map over function is gonna take yeah okay yeah boolean 1 difference 1 then boolean 2 difference 2. Yep. And then it's going to return a vector consisting of and p1 p2 because they have to be sequences, right? And so this has to be true. Mm. If the sequence continues, right? If the sequence continues, the sequence continues if and p1 is a sequence, b2 is a sequence, and d1 and d2 are equal. Okay, so this is the sequence. Yeah. Um, and it returns sequence continues, and also if yeah, when the sequence continues, just pick one of the differences, otherwise it will be implicitly nil. Map this function over current row and the rest of the current row. Okay, now and then if not, like if the thing is empty, Just return the accumulate. This is in fact the base case. Yes, yes, it's a mistake. Should be 3 hours. And this is, I'm going to turn this into a defen, which is, what was the thing you wanted? Edit sub column 3. It takes the initial row as input. This evaluates, this is fine. It's also evaluates, and let us try just running this. Yeah, 3 input, cool, cool, cool. And let's see, I will copy this, paste it, see what happens. It is 4. Why is it 4? Because we didn't count the side. Okay, fine. Fair, fair. So I'm just gonna cheat and put this as yes. Okay. And now this should be correct. 8. Okay. Let's try this. $15, fair. Let's try this. 22, okay. What am I doing? Print line. This action answer. Audible. Give me a moment, I'll be back. Okay, I'm back. And the answer is time limit exceeded. Okay, so I can probably slightly optimize this by skipping the true false checks. Um, for example, do I actually need this true and false? Probably not. So, in this case, let's say I just keep track of the differences, nothing else. 0, 0. So this is like meaningless. I'm sorry. I'll compute these differences. If the difference is actually a difference, there's a number. If it's not, it's a nil. Okay. Uh, if these two are equal, this this gets in here. These two are not. Just a moment, please. Sorry about that. A lot of logistical problems today. Yeah. So let's refactor this so that I simply don't have to do that. Okay, cool. So let's go one by one. I need to get the input so I can forget this. And this whole thing can be replaced with just the minus VA, minus second argument minus first argument. Yep, that's cool. And then the initial row. Okay, I'll have to rewrite this because this is not going to work anymore. Um, now, okay, 3, 3 minus 6, this is correct. All right, so given this, let's build this up. Loop accumulator bound to let yeah initial row be get problem 3 input cool loop over accumulator increment. A lot of this will be similar. And initial row. Now I simply count the non-nils. What happens if I try plus 10 nil? Doesn't work. Gives plus main like plus same problem. Now just filter it. Yeah. What's the thing for not nil again? Uh, wait, what? Oh, okay. Count, filter sum. Fair enough. It's empty. Just return the accumulator. Otherwise, well, the structure is going to be similar. Otherwise, recur, but this time accumulator count sum. Yep. And then map v, where it's just this time it's just d1 and d2, right? Nothing else. We don't have to do the whole sequence continues, whatever, whatnot, because if d1 and d2 are the same, it's just d1, else it's nil. Map this over current row. The rest of the current, what remains of the current row afterwards. This we're going to try 8. Correct answer. This should be faster than the last solution because we are not doing a lot of the expensive pair computations. 15, also correct. And 22, also correct. All right, fine. So we turn this into a function. Arith sub 3, and this initial row becomes actually the input. I think everything else should remain unchanged. Yep. Now, oh, what am I doing? Sorry. Highlights. Yeah, comment this whole thing out. Cool, done. And move this here. 22 is the answer. Fine. Okay. Let us see if this time it will work. Because this is straightforwardly linear traversal through the whole thing. None of the pair computing, none of that. It's possible that it might still be too much, I don't know. Let's just, I don't know if this will work. Please don't TLE me, bro. Damn it. Damn it, damn it, damn it, god damn it. Too much garbage, eh? All right, fine. Is there a closed form solution? There should be actually, because the minute the difference is different, you're not going. So you have to count runs. And let's try. I think identity is a function, right? Yep. Same thing. Yep. Okay. Yeah, it's just the values. But the problem is it's not continuous. Okay. So this is gonna have to be slightly more. Slightly, yeah. This has to be a closed form. It has to be a closed form, right? Okay, okay. We can get a closed form answer by counting runs of the same thing. So 3 minus 6. This is actually enough to tell us 1, 2, 3 right here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yep. So this is going to give us basically, this is the base of the triangle. And it's gonna, yeah, okay, it's got that. Okay, fine. So if you think of this as the base of a triangle, 1, 2, 3, 4, 5, 6, 7. Yep. We have to have a reducer. Which keeps track of the one seen so far. Hmm. Okay, okay, okay. So let's just try this here. Alas. Okay, now we have the numbers. We'll need one accumulator. Let actually loop. Let there's no such thing as two differences. And you go through these. This could be a reduce, but maybe let's just leave it. No. The accumulator. This is the n so far is just a 0, and remaining is the whole of the two diffs. Okay, now let's just consider the case where something remains. I'll come back to the base case later. Con current difference is, maybe let this be, yeah, current difference is diffs. Yeah, okay, fine. Okay, so right. Okay, nothing remains. Just return the accumulator plus um, n into n plus 1 by 2 is what we are looking for. Let's put this n. It's so much easier. So n is a count of the streaks so far, right? N into n plus 1, whole thing divided by 2, just in case there is a streak. What? That's the accumulator, that's it. That's all. Otherwise, I'm not entirely quite sure how this is going. So we are at the first. You're looking at the first one. Are we looking at the first one? Looking at the second one? Let's say you've already seen the first one. Let's just assume. And so the current difference is that, and the, yeah, okay, fine. In the other case, it'll be a recur with now. Okay, fine, fine. Actually, a con. In case current difference is equal to first of the remaining differences, we will recur with accumulator as accumulator, n incremented. Current difference is fine, and the rest is remaining. And if it's not, then we'll recur. Wait. Can we might be able to skip that, actually. Yeah, yeah, yeah. You might be able to skip this whole condition because, yeah, exactly. Fine. Yeah, because nil funny. This is the accumulator. Not the first remaining. Yeah. So in fact, this is not even an on, it's just an if. Wait, no, no. Yeah, it's got to be like that. Yep. This is the accumulator, and it's just going to be zero now. Yep. Current difference is going to be first remaining actually. And then is, yeah. Yeah. Oops. Indent this. Compile it. Will it even work? I no clue. Copy this. But no man. And it gives me 7, which is not correct. But it's close to correct. Okay. Oh, right. Oops. It should be a 1. Now it's right. That's right. Okay, fine. So now the closed forms will reach me. What just happened? Oops. Two. No. Wait, what is happening? Yep, 22. This should actually work within the time limit. Should. I hope. I don't know. Mhm. Okay, now it's just one straight for loop. Let's hope. Ah, come on, man. Please, bro. There's literally one single round over the input. What even? Wrong ones. What did I do wrong? Wait, did I not recompile? Huh? Did I not recompile this? I did, right? Which? What is the problem? Used to work on all the simple inputs. Like what? Yeah. What the hell? Hmm. Okay. What? A wrong answer. One wrong answer. Right. Eh, okay. If I give it a zero input. eh, ah, ah, right. Right, 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 right. Is the zero input? Let's try that out, shall we? Wait, what? Hmm. Oh, yeah, this worked for everything except zero, I think. Yeah. Mm-hmm. Yep. Probably something a little bit off, I think, about what I'm doing here. Maybe. Because there's this little repetition. Maybe it's something slightly inelegant. I don't know. Maybe I should have used a reducer. Who knows, right? But let's see. Okay, this should really not time it because it's very close to just straight imperative code. Hmm. Come on, man. Come on. What? What the hell? Huh? What is? Where am I hitting the wrong answer? This n is always at least one, right? What is happening? Yeah. What is the one case that is messing this up? Yeah. If the sequence is not remaining, fix up whatever is left if there's any n, and then return that like the streak that you've seen so far, right? Otherwise, if the current diff and the first of the remaining one is the same, recur with the accumulator with n incremented, current diff remains the same, rest remain. This is fine. Else, recur with a different accumulator. Yeah, right. Set n to 1 because we've seen 1, and then the rest of the remaining. What is going on? Okay, what am I getting wrong here? It's a straight pump. If there is nothing, just return nothing. Ah, oh my god. Fine, fine, fine. Okay. Cool, we got it. The intro. Yeah, that's right. Um, Actually, case found as, you know, 0, 0, 1. Oh, this is so silly. Um, I mean, it's not silly. I get it. And then the default case, right? Yeah. Okay. Fine. Let two diffs be, was the thing, map fee means most second AIs and AIs not. Okay, I think we should actually finally do it. Mhm. 8. I compiled them both, right? Yep. 15. Thankfully. And 22. Also, and just 0, 1. mm, This work. Damn it, dude. No, it's over. I'll just look at this a little bit and see. Mm, Almost got it. Seven, 8. Isn't this higher than when it timed out last time? Mm, okay. How do I clear? Reset the canvas. Damn, dude. Like by a few seconds. All right. Well, until next time. See you guys. Bye.